Let's continue. Okay, yeah. So another issue is how many people here have written their own .h files? Good, good. So what do you put in a .h file? When do you create a .h file? What is a .h file? It's a what? It's a header file. And what job in life does it serve? Good. Good. So it sort of summarizes all the functions there. Particularly for someone who's going to use your code, it summarizes all the functions they should care about in your module that are exported, that are things that might be used elsewhere. That's a good thing, so they know, okay, what's available. Maybe even puts comments on them so they know something about how they're used, in other words, specifications. These are good things we'll come back to later. One of the issues that comes in here is, you folks have probably not had to struggle with this, but it's a reality for many C programs. Often in a given project you have many .h files, and one will depend on the other. And suppose A.h needs some information from what's in B.h, and B.h needs some information from what's in A.h. If you just naively put in just a pound to include in A.h, or to bring in everything in B.h, and vice versa, you're going to be setting up a what? Begins with L, two O's, and a P. Sorry? That's an L, two O's, and a P. Thank you. I'll tell you a story. So I started doing programming when I was in elementary school. Yeah, I know, I think the world was still cool back then. And I'd been doing something like programming on calculators. Yeah, that's kind of weird, but did it with something. And finally, I was going to get a chance to actually do it on some computers, some larger computers. Now, this is back in the day where we had terminals, CRT terminals, cathode ray tube terminals, and we had these printers that would print things out while you were doing the programming, print each successive line out, print it out, just like that. And so I went and took this class. It turns out it was a summer class. I think I took it after getting back to camp. It was programming on calculator. And it was the continuing ed class. So it had people from all different ages. And everyone there was like, at least 3 times my age. And there are some people, in their 60s. And we were all there, and I just wanted to get my hands on these computers, from them in various ways, and kind of try some programming on them as best I could. But then, after about 3 weeks, 4 weeks, the instructor seemed ancient, maybe. I think he was, in his 50s. He seemed like an ancient being. He said, we're going to have an exam. I ended up paying attention to what was presented in class, especially like macro. There wasn't no macro. Exam? Okay. I never had an exam before. No about an exam. So he said, okay, we're going to have an exam. And he said he's going to have a review session. Okay, well, maybe this is my chance. So he started this review session. He was pacing back and forth. Maybe I've brought some habits from him. And he was going through various problems that he might give on an exam. They were saying, suppose, you wanted, if, a certain person's age is greater than 18, do one thing, otherwise do another. How would you do that? Use an if statement. Right. So he was going up and down and doing this. And then he said, suppose you wanted to go do something 100 times over, go from 0 to 1 to 100, how would you do that? What would you use to do that? I was walking back. And then he stopped and he looked at it and said, how do you do that? How do you go from 1 to 100, do it 100 times? And he said, I'll give you a hint. It has an L, 2 O's, and a P. I looked at him and I said, pool. I think he did this right. Here's this 8-year-old. And of course, the subsequent ironies are delicious. So I love my kids. That's for sure. Anyway, that was a vignette from early in my life, probably before your parents were born or something like that. Moving right along. If we had a situation where we had a L, 2 O's, and a P among .h files, that could cause a problem. Why could this cause a problem up there? We have that L, 2 O's, and P between the .h files. Yeah, but not only that, what would happen if we tried to compile a program where the program then said, so we have our, main.c or something like that. And it did a pound include, a.h. What would happen? So we go to compile a program, GCC this, and what happens? It's done and then never finished, depending on what version of GCC you have. There are certain warnings on or whatever. Otherwise, it won't finish. It'll just sit there, just tries to use one, one's including the other, the other's the first one. Just go back and forth, ad nauseum. So this is a problem. You may think that's obvious. I mean, after all, why would you do A includes B and B includes A? Well, it might not be so obvious, folks. Maybe A includes B, and maybe B includes C, and unbeknownst to the person who wrote B.H, C includes A. They may not know, they may not deliver it, or maybe it's written by different people or what have you. So how do we avoid these loops? Well, we do it, ladies and gentlemen, through macros. And I showed them here. So you do this if not def foo.h. So you define a macro called, if you're in foo.h, you define a macro if not def foo.h. If you're in a.h, you define if not def underbar underbar a underbar h underbar underbar. So many programmers will use this convention, others will use different ones. And then, so if this is not defined, then only then will it actually go and pay attention to what's in there. If it is defined, then it just ignores the file. So it breaks the loop. So in other words, if I had main.c, and main.c included a.h, and a.h included b.h, that would occur after this pound define, and b.h would then try to include a.h, it would actually load it, it would come to this if not def, and would say, oh, I already know that. It's already defined for me, so I'm not going to include it that second time. That breaks the loop. Does that make sense? Now, you may think this is some weird obscurity. It's not. This is par for the course for dealing with .h files and managing .h files in C. You got to realize that can be loops very, very easily. Typically, there are in the files you're using if you don't enforce it. And so you have this gating mechanism. This mechanism which prevents it from being included twice, or prevents it from being processed twice by having this if not def up here, and then you have a pound define here, which sort of, as soon as you start processing the file, as soon as you get within it, you declare this thing that we tested the next time you include it. So this breaks the loop, okay? So you will see these, if you remove them, you could cause loop, and you could cause your compilation, when you use GCC, it won't ever stop. And for most people, that's bad there. They want their compilation to finish in some finite time. Okay. Another issue having to do with variables and variable uses has to do with, I was going to introduce this now, but I think the right place to do it is actually in a later lecture, just because it fits in there better. So I'm gonna go on to some idioms now, and I'll come back to that issue with lifetimes and spans or variables in a